Welcome to section 3, Prototypal Inheritance. During this section I will explain you what are the prototypes, what are the different properties that can be used in order to deal with prototypes, and also how the prototypal inheritance is being done between objects, between constructor functions, and between classes. In the first video I will show you what is the context in JavaScript, what does it mean that something is attached to this keyword, and how to change context within objects. In order to understand what is this keyword in JavaScript, let's focus on this example. We have a function constructor. This function, it expects one argument. The argument is passed to property x of this, and inside of the constructor we have function, another function, and this function is called at the end of the constructor. So calling another function, it will display this x property. So if we make an instance of constructor, the question is, what will be displayed when we call another function from within the constructor function? The result will be undefined. It is different than most of people could expect, because the most intuitive thing would be to display 12 as it is the value that is passed to this x. Nevertheless, this is the pointer of the object that will be created by the constructor. So, this function, when called with new keyword, will create a new context for the object that will be returned, but the function that lays inside will have its own context. Therefore, calling another function will produce an effect of logging x property of this, so the scope of the function that is here. We have nothing like property x that is attached to scope of this function. We have only property x that is attached to this function. Therefore, logging property x here will return undefined. So, constructor function is creating an object. This object has properties, and those properties can be accessed via this keyword. When there is a function inside the constructor function, this function will gain its own context. So if we want to access the external context from within this function, we will need to create another variable, and the another variable has to point the correct scope. And now from within another function, we can console log x that is part of the scope of constructor function. So when we run the code now, it will display 12. This is a very common way of doing so when we are dealing with constructor functions, but there are also different ways of binding the context, so we can define a function in which context this function should be called. So we'll go back to the previous construction, and we want to call another function within the context of this function. We can make this with the help of operator call, and it looks like this: another function dot call, and as the first argument we can provide with the scope that should be used as this inside of the function. So when we provide with the pointer of the scope of the external function, we will get 12 as we are still pointing to the external scope. We can use call also in different situations, not only when the function is inside of another function, but also, for example, here, when we have an object. In this object we have property x and method show, and we have another object that has also property x. So we can use method show from the object first in order to display x value that lays inside the second object. So we can do it by the construction object.show. So now we have the access to this method. Now we can call the call method, and this call method as the first argument will get the scope of the object that should be used. And thanks to this, operator call can take more than one argument. It is important when we have methods that expect some arguments. So if we have method show now takes two arguments, x and y. Those arguments then will be passed to console log along with this x. And if we want to launch this method aShow within new context and with provided values, we can provide them here. So now, if we call method show, it will be called within scope B and with x and y provided. There are also other operators that can be used. One of them is apply. Apply works the same as call. The one difference between call and apply is that apply expects arguments as an array of arguments and not like in call arguments separated by comma. So this apply will work the same as previous call. And the last type of operator that can be used is the operator bind. Operator bind looks very similar to operator call. So it also expects as the first argument the new context of the function. Next parameters are the parameters that are expected by a method itself. But operator bind, it does not launch the function. Instead, it returns the function with new context and with arguments already provided. So if we now call this function showB will be already taken from object A, but this method will point to object B and arguments will be already fulfilled. So running this function, just this function, will produce an output that was shown before. What is very important to notice here is that we can use also different kind of function here in order not to make a new scope of the function. If we use our well-known lambda function, we will get a proper output. How does it happen? So arrow function, they do not have their own scopes. So every single arrow function will inherit the scope of the function it is placed in. Thanks to this, when we want to access properties of the object, we will most probably use arrow function here. So using arrow function, we can also solve the issue that was introduced at the very beginning. We'll make a function like this. and run our program, we will get as an output 12.